know how an exponential function looks like. And even if you don't, all right, it doesn't have to be a, this is just a general one here, okay, you're probably used to e to the power of x. They all look the same, okay. If you put x equal to 0, then e to the power of 0 will equal 1. So you know that it crosses there. Now, it gets closer and closer to the x-axis, but it does not cross over. As a matter of fact, we have an asymptote right there. So we must make sure that we write the asymptote of y equals to 0 there. Okay, they all look the same. A can be any number. If it's greater than 1, then the graph still looks the same as the e to the x, exactly like that. If it's between 0 and 1, then it will look like this, okay, inverted, or reflection, sorry, I should say, reflected in the y-axis. The domain, of course, for all these type of ones are the reals. There it is there. The range, well, if it hasn't been translated, it will be reals positive because we've got an asymptote at y equals 0, but then all those reals positive will exist. That's assuming there is no translations, okay? If we get translations, then of course we will have to re-look at it. That is our range. Right, any questions at the moment? Okay, most important thing in this next point here, that it is 1-to-1, so make sure that you write that down. Okay, we'll point that out. Now, as I said, we can do translations, okay, and we should know that if we've got this type of graph, go back to my red, okay, we can have a translation along the x and we can have a translation along the y. It doesn't really matter. Okay, when we do it along the x, then we get the x minus h here when we're finding our image, and of course we've got the plus k. We know that this plus k, just like everything else, shifts it up or down. I know I shouldn't be writing translation, but I'll just write shifts it up if it's positive, and of course down if it's negative. Okay, so, and that k becomes the new asymptote, okay, very, very important. So the range will be from this k all the way up to infinity as it shows there. Okay, here's a graph. Any questions, please jump in, right? Here's a graph of example 1. This is question 1a from your book. It says sketch the graph of y and state the range of y equals 2 to the power of x minus 1 minus 2. Well, we know immediately that we have a translation of 2 units in the negative direction of the y-axis, and that is the asymptote as well. Our asymptote, go back to poor writing, keep my screen steady, and asymptote is at y equals -2. So we can see at y equals -2, we should have put the asymptote in there. We also know that it's being translated 1 unit in the positive direction because x minus 1 equals 0, x equals 1 in the positive direction along the x-axis. But even if we don't remember all these, okay, the asymptote's one of the things we should remember, all the others, we can just put numbers in. Put in x equals to 0. When x equals 0, we're going to get 2 to the power of -1 minus 2. So we're going to get 1/2 minus 2. We get -1 1/2. So when x equals 0 and out crosses at -1 1/2. Okay, we can put y equals to 0 if we want, as long as we've got another point. It doesn't matter. So then we get 2 equals 2 to the power of x minus 1. So equating x minus 1 equals 1, x equals 2. So when y equals 0, x equals 2, we can get that point there. 2 points is enough to show the graph. Okay, if we don't remember how it looks like, we can get an idea because we should know it's still e to the power, okay, or a to the power of x. Any questions there? All right. Then, of course, we get reflections. Okay, we know where we're heading, don't we? Okay, so reflections, we're reflecting in the x-axis. Of course, we know that we put it on the y. Okay, and therefore, when we rearrange this one, finding its image, we're going to get y equals -a to the power of x. Okay, So what's happening? That graph cut out, but it should be down there. I don't know why it's not. Oops, not past the x-axis. Okay, down there, because it's reflected in that line. Y equals to 0. Okay, so this equation here, let me just erase, clear all that. Example 2. I haven't told you the range, but the range, of course, if it comes all the way down here, then of course the range is going to be negative infinity to 0. This one here, sketch the graph of y equals negative 4 to the power of x. Okay, now we know it's reflected in the x-axis because of that negative. Okay, so instead of like this, it's going to look like that. The blue one. There's no translation along the x and there's no translation along the y, so that's it. Instead of crossing at 0, 1, it's going to cross at 0, negative 1. But if we forget that, we can just put in x equal to 0. We get y equals negative 4 to the power of 0, which is negative 1. Okay, so we get that. Any questions there? Okay, if we have a reflection in the y-axis, as we know, it belongs to the x part. And therefore, when it belongs to the x part, this converts to that, which we can write as either 1 divided by ax or 1 divided by a to the power of x. It's the same thing, okay? Horizontal asymptote still exists. No, there's no translation. As you can see, there's no translation. The range this time is going to be from 0 to infinity. So I've got here example 3, sketch the graph of y equals 4 to the power of negative x. So I'm going to give you a minute to sketch that. Okay, quickly, 1 minute, have a sketch of that, see what you think. Remember, it is reflected in the y-axis here. And I'll quickly draw something up while you're doing it. This is the original, y equals 4 to the power of x. This would look like this, crossing at 0, 1. But when you do the other one, I'll do it in blue, and it's reflected in the y-axis, we're going to get something like this. It still crosses at 0 and 1. And there is still an asymptote at y equals to 0. The domain is still reals. The range is reals positive. 0 to infinity if you want to write that. Any questions there? Okay. Dilations. Now we know about dilations, of course. Same thing is we can dilate from the x-axis, of course. Dilating from the x-axis, we write it on the y. We know that. And so therefore the image of this becomes y equals k, a to the x. Still y equals 0 is the horizontal translation. The range will be 0 to infinity. So example 4 said for you guys to do, sketch the graph of each of the following. Okay, you guys can try and do that one. I should be able to do this one anyway. Okay, I'll give you about a minute to do that one. And then I will do it quickly. Change my color. Okay, well, this one here, you're not going to be able to see anything on this graph unless I draw another one on there. This is still going to be like this. It will cross at 0 and 1. Okay, sorry, it won't cross at 0, it won't cross at 0 and 3. Because when I put x equal to 0, I get 3 times 5 to the power of 0, which is 3 times 1, which is 3. Okay, so that will show up, but I can pick another one. I can pick x equal to 1. I'm going to put x equal to 1, and then you get 3 times 5, which is 15. So x is 1. This will be all the way up to 15. So 1 and 15 that is enough to show, God, that's bad. That is enough to show what it looks like. And the other one, okay, it doesn't matter about the other one, it's exactly the same. Okay, it will look the same. So this time I'll do it in blue. It's going to look something like this, and I forgot my asymptote there of y equals 0. In here, y equals 0. This time when x equals 0, we're going to get 0.2. Because 8 to the power of 0 is 1. 1 times 0.2 is 0.2. And you can pick any other number to graph it. It doesn't matter what you pick on there. It's up to you. Okay, so they're the main things. Domain for this one, rules, domain for this one, rules, range for this one, 0 to infinity, all reals positive, range for this one, 0 to infinity, all reals positive. Okay, if I had drawn them very similar or one on top of the other, you would have seen the difference, okay, because the blue one would have been underneath the green one. But when you draw them separately, no one's really going to see it. Okay, and my blue one seems more like a straight line. Of course, it shouldn't be like that. It should be more curved. So please draw it better than that. Okay, combinations of transformations. So even though I've got this on here, all the answers for you, I'm going to do them separately for you as well. So sketch the graph and state the range of each one. So let me give myself some room here, and I will do the first one completely in green, actually. Okay, so I know what 2 to the power of that x is, and I know what 2 to the power of negative x is. So this is part A, and I'll just rub it off. So I'm going to only draw y equals 2 to the power of negative x. So when I draw that, and I'm not going to draw it 100%, just very quickly, okay, it's going to look something like this. That's the negative x. It's going to cross at 0 and 1. What does the 3 do? It shifts it up 3. So here's the new graph. This is y equals 2 to the power of negative x plus 3. Okay, so I'm getting the same graph. I've got the same asymptote, y equals 0, but this is going to be, sorry, y equals 3. Y equals 3, not that. Run that out. Okay, asymptote is at y equals to 3 because it's been translated. The graph looks the same, other way around. And this, when I add 3 to here, it's going to be 0 and 4. So that's that graph there. Any questions on that one? Okay, pick another point. You can pick any point, you know, x equals -1, x equals 1, it doesn't matter, and just put a couple of points on there just to show how the graph looks like a little better. All right, I'll remove that one, and then I'll do part B in stages. I know it's already there, but I'll do it in stages. Okay, in red. So this is part B, and I'm only going to do y equals 4 to the power of 3x. Okay, so y equals 4 to the power of 3x. I'll do it in pink. 4 to the power of 3x looks like this. It's crossing at 0 and 1. But then, of course, I've got a translation of -1. So my new one is going to be translated down to -1. Y equals -1. Okay, it will still look like this, but this point here, of course, will be translated down to -1. So it's going to cross at the 0, 0. So I'm going to go, there we go, it's going to cross at 0, 0. Pick another couple of points on there. And so that is the graph of y equals 4 to the power of 3x minus 1. Any questions there? And I'll do the same for part C. So this is part C. And the first thing I'm going to do is y equals 10 to the power of x. I know it's been translated, but that doesn't really matter at the moment. So 10 to the power of x, Asymptote, yep, right there, y equals 0, looks like that. That's not an issue, okay? Then I'm going to do the next part of it, which is the reflection part, y equals negative 10 to the power of x. Again, I'm not worried about that translation as much. So that means it is reflected in there. So we get that type of graph. Okay, any questions so far? Of course, the asymptote is still there, y equals 0. And now our final one, and I'll do everything. Okay, it's been translated 2 units down. So it's going to be at -2, -2 there. It's going to be underneath that graph still. So it's going to look like this. Okay. Now, I could have put points in and do it all, but you can quickly do it anyway. Okay. So when you put x equals to 0 in there, you're going to get -10 to the power of -1 minus 2. Means -1/10 minus 2, which means it's going to be 20 on 10, -21 on 10. So this is 0 and -21 on 10. And when I put x equals to 1, I get y equals -10 to the power of 0 minus 2, which means it's -1 minus 2, which is -3. So this point here, -1 is and -3. That's there. So I've got a couple of points in there, so I can quickly draw that. Right, any questions there? And it should be on your paper further down. Oh, it said the range. Okay, I didn't do the range. Range for this one now, you can quickly see it. It is from 3 to infinity. That's part A. Part B is from -1. You can quickly see it there, to infinity. And part C is from -infinity up to -2, which is the asymptote. Questions from 5A? No one's typed anything.